What is scattering in physics in light? So, whenever there is an incident light, if there is no obstacle, it will go straight. But if there is a particle in the atmosphere or in the air, what will happen? The incident light will be spread in different direction, will be scattered in different direction, random direction, because of the interaction of this incident light with these molecules, gas molecules, dust, etc. So the ability of light to spread in various directions is known as the scattering of light. This is a very common phenomena. So scattering of light is the phenomena in which light rays get deviated. That is, it is going on a straight path, but after striking or after interacting with an obstacle, like it can be a dust, it can be a gas molecule, it can be a water molecule. So because of the obstacle, the light ray gets deviated from its path and into random directions. This is very important. So this is called the scattering of light. So this, it would have been a solid, it's okay, it may strike back somewhere, but because mostly we have permeable, semi-permeable kind of gas molecule, dust, water vapor, therefore it gets deviated and scattered. So we have very famous phenomena which we observe, Tyndall effect and the red hues of sunrise and sunset. That is, in day, sun or the atmosphere looks differently than the evening. So let me tell you about the Tyndall effect. See, this is a solution, that is, two content are mixed and they are properly mixed. So when you put a light source, when the light source passes through this glass of solution, then for example a water is there, not visible. But when you make it colloid, that is, you are mixing water with milk or even milk because it has already water, colloid, and then this suspension, that is, you can add some flour with the water. Now the colloid and suspension, you are able to see the particles, proper particles. Why? Because the Tyndall effect is the scattering of this light by the particles in this colloid or suspension. Now here the rays of sun are coming. Now the sunlight is white. The white light, we have all the colors like VIBGYOR, and these are all colors, and they have different frequency and different wavelength. Now we are talking about blue and red. So the lambda wavelength of red light is the highest, and the wavelength of the blue, indigo, violet, they are less. That is, the frequency of blue light is higher and the frequency of red is lower. The blue light and the other lights below it, they get scattered more because the wavelength is less. So when it will strike, it is supposed to be striking these dust, gas or water vapor. But the red light, because the wavelength is high, so it may jump over. It will interact with very few of these obstacles. So what happens? Whenever the sunlight comes, the blue light and the VIB, all these, they get scattered more. And because of this, our atmosphere or Asman is looking like blue, indigo and VIBGYOR. Mostly we see blue. Now in the evening time and the morning time, most of the blue light is scattered away from us. So we just see the red light coming.